In this video, I want to quick review some of the things we've talked about with volume, and then go back to Calc 2 and talk some converge or diverge. And then I want to start talking about conic sections, which is a review of pre-calculus, but we will be using to graph three-dimensional shapes soon. So to begin with, find the volume of the parallelepiped. If you remember, I'm going to put this down here. How to do that, we cross two of the vectors, doesn't matter really which ones, and then we dot them with the third vector. So I'm going to do it this way. I'm going to dot A with the cross product of B and C. And if you remember this right here, this helps us find the area of the base, and then this helps us to multiply that height in. And kind of the shorthand way to write this is to write our A vector, and then we'll do the B and C. Like this. So this would give you 5 multiplied by, and then remember we do this, 3 minus negative 3. And then minus 2, because remember that y1 is always negative. And we do 6 minus negative 2. Plus, and we've got a negative 1. And then we do negative 6 minus negative 2. That. So we have 5 multiplied by 6 minus 2 multiplied by 8 minus 1 multiplied by negative 4. So 30 minus 16 is 14 plus 4 is 18. And just remember, if we'd gotten a negative answer, we simply would have made it positive. All right. Next, let's talk about converge or diverge. Let's review that a little bit. This first series could be written with a power 1 over n to the 4/5. This is a p series, and the power, remember in a p series it's 1 over n to a power. To converge, the power must be greater than 1. So this diverges. Next, we've got a geometric series. Remember, geometric series are where we have a number raised to the nth power, and as long as that number is greater than negative 1, but less than positive 1, it converges. So this converges. The next one, how I would think about it is that sine is always between negative 1 and 1. So sine squared is between 0 and 1. So this is always less than or equal to 1 over 3 to the n, and 1 over 3 to the n converges, so this thing must converge as well. Okay? And finally, 2n over n squared minus 1. This I would do a limit comparison. If you remember, we would kind of reduce. We say 2n over n squared, so 2 over n. And since this diverges, this series diverges as well. All right, let's talk conic sections. The conic sections are parabola, circles, ellipses, and hyperbolas. Conic sections really are simply the things created when we slice cones. If we slice them this way, we get a parabola. This way, we get a circle. A little tilted, we get an ellipse. And slicing both, we get a hyperbola. This is a picture that I took at the Math Museum in New York City. There's a room with lasers around the whole door jamb, and you can put cones in. So I put this cone in, and you can see that a parabola is traced. So these are the things made. Kind of slicing cones. These are the conic sections. I want to focus on parabolas to begin with, and I really want to focus on a couple of things: the focus, the directrix, the vertex, and what these things mean and what they do for us. To begin with, I just want to remind you, of course, the vertex we know, this is kind of where the bottom or uppermost or sidemost, depending which way this parabola opens. This is kind of that, in this case, the lowest part, the minimum. Of course, if we're going this way, it'd be the maximum. If we're sideways, it'd be the most left, and so on. But that's the vertex. The focus is defined as kind of, in, I guess, a physics standpoint, it's where if light or something came in and bounced, it would land at the focus. Right? If it came down here, it would bounce back and end up at the focus. If it came here, it's almost like if you were shooting a billiard ball, it would hit the focus. Okay? This is where in a light, like a flashlight, you have kind of the mirrored part in your flashlight. The focus is where the bulb is placed, because that when the light shines out, it hits the mirrored part and comes straight out. Okay? So it gives us the best beam of light. So that's kind of the physics application of the focus. The geometric application of the focus is that if I pick a point on my parabola and I draw a line to the focus, it will be equidistant to what's called the directrix, a line below. And the directrix is, in this case, we called it F units from the vertex, and so is the focus. So you can see they have the same distance from the vertex, and putting any point on a parabola, if I drew a line to the focus and then straight down to the directrix, those lines would be the same length. So I did a little bit of algebra here, you can see, to show you how we can calculate the actual functions. So I began by using distance formula. I said, well, the distance between x, y, and the focus. And I named the focus to be at 0f, f units up. Okay, so the distance formula, x to 0, y to f. And I said that needs to be equal, right? This distance right here needs to be equal to this distance, which is simply y plus f. So I squared both sides. That's how I got to this step. And obviously x minus 0 is x. The next step, I actually multiplied this out. Here it is. And I multiplied this one out. Here it is. I combine like terms. F squared and f squared. You subtract the f squared over, and those two things are gone. Subtract y squared over, and those are gone. So now I was left here. I add the 2yf over, and I get x squared equals 4yf. So f is the distance, remember, between the vertex and the focus. So to calculate an equation of a parabola, all I need to know is how far away the focus is from the vertex, and that's f. Now, let me show you the generation here. So again, you can see the vertex right here, the directrix down here, and you can see this being drawn, how those lines are always the same. So your textbook uses P as this distance, and I just used F for focus, so I just wanted to now kind of be consistent with what book you're going to use. So P is the distance from the vertex to the focus. Of course, the directrix is P units in the opposite direction. If it's opening up or down, it's a y equals x squared. If it's opening side to side, this is a positive y squared, of course, and this is a negative y squared. In the next video, we'll actually do some calculating and finding equations.